It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Good morning, everybody, and welcome to another fun-filled, exciting episode of Pure Performance. I'm Brian Wilson, and as always, to the left of me, here is sitting in person, virtually, Andy Grabner. Hello, Andy. Good morning.
Hey, Brian. How do you know it's the left and not the right? What's wrong? I mean, how does this work? I think it's the right of you.
It's radio. Well, it's audio only, so nobody knows. So just go with it. Andy, I'm coming from my dining room today. No feast, but I've been kicked out of my my normal spot today. So we'll see what kind of distractions. I might get distracted by a dog outside or something. So hopefully,
that's okay.
Yeah.
No worries. Well, I survived Cinco de Mayo. I think the last recording we did was just before the Cinco de Mayo party in our office. Survived that. Actually, we did a salsa lessons with some of the office staff after
you were teaching?
some Kimbo dancing. Huh?
And you were teaching, I imagine?
I was teaching, yeah. At least I tried, and I think people enjoyed it. At least they stayed, and no, it was a fun thing. So, but talking about fun things, what do we do today?
Well, we have another one of our 101 sessions today, right? And we're going to be talking about Node. Even though it's been around for a while, I think I think we both agree it's a pretty important topic. And also, we're going to touch upon serverless, which I think is kind of this mind-blowing, one of the most bizarre things I've ever heard of, but it seems to be picking up. So we're going to talk about those. And who's here today to talk to us about these?
Not Genghis Khan, but it's Daniel Khan. I'm sure he has heard this joke many, many times before. So Daniel is actually one of my colleagues. We're both working in the Innovation Lab. And without further ado, Daniel, are you with us? Are you still with us on the air?
Sure, I'm here, and I've heard this joke before.
Now, see, that's not the first one that popped in my mind. I was thinking, Khan!
Oh, yeah, of course.
Right? Because to me, it was, I always look at your... From the U.S. point of view of English, I look at it as Khan, not Can. But so to me, it's the Star Trek. I'm sure you get that as well.
So many associations with my name. Okay.
Yes. Do you know that one or no?
Yeah, sure. The Wrath of Khan or something like that.
It's excellent.
So Daniel, before we go into Node.js, maybe a couple of words about yourself, so people that don't know you.
Yeah, as you said, Andy, I'm working at the Innovation Lab of Dynatrace, and there I'm owning this topic around Node.js and also serverless. I'm in the industry for about 17 years now, and I'm doing Node for, I think, 4 or 5 years now, and I joined Dynatrace 2 years ago to help covering this whole topic around Node.js, and now there I'm really try to do a lot with the community. So I'm frequently at conferences. I'm speaking at conferences about Node.js and performance. I'm also in some working groups around the Node project. And at least I try my best to help the project there as well. So that's what I do.
So that's cool. So that means you actually you have a stake in influencing at least the future direction of Node.js if you're part of that community.
To some degree. Node.js is a very open community, I have to say, so everyone is free to join. I once started working with them, and it was quite easy to get started. So it's not a big deal.
So and again, this is a one-on-one session. So maybe to really just get it off the plate here, what is Node in general? Can you give us a quick intro for people that may have not heard about Node or have heard about it but don't really know what it is? What is Node?
Yeah, I'd like to maybe start with how Ryan Dahl, maybe the inventor of Node, kind of introduced it in 2009, because he said basically Node.js is server-side JavaScript. So it's JavaScript you can execute on the server, and so you can create JavaScript server-based JavaScript applications. And To accomplish that, you need some runtime that runs this JavaScript, and for that, Node uses the V8 engine. That's the same JavaScript engine that's used in Google V8 in the Google Chrome browser. And the neat thing about JavaScript is, and we know this from the browser, that it's evented. This means it can react to events, and it has functions as first-class members. And Ryan Dahl, when he created Node.js, thought, yeah, that's a good match. So I can use JavaScript to really create more or less like evented server applications that react to incoming events and then execute functions on that. And that's more or less the core of the whole Node.js project. Node.js is highly asynchronous, so it's really a good fit, but maybe we talk about that later, for everything that consumes APIs or talks with databases. And it's very, I would say, it doesn't consume much resources on servers because of this evented model it uses. You can very much compare it with maybe Nginx here. That is, or like Nginx versus Apache. That's maybe some kind of similarity in how Node works compared to maybe Java or PHP.
Now well, thanks for that. So that's understood. So if I write a Node program, that means I write my code, my JavaScript code. And then basically on the server, the only thing I do is I just launch the Node process, or does Node run within the context of a web server like Nginx, or how would that work?
Yeah, the neat thing is that Node comes with a built-in web server. So it has an HTTP module in its core. So in your Node application, you basically start or initiate a listening connection like on some port. And then you start this application with Node and then the file name you want to start where the main file is actually. And then the Node process will listen for incoming requests on this port. And usually in your application, you also add a function that has to be executed when this incoming connection or this incoming request comes in. And as it is evented, this means this function can also, again, trigger different functions or do a call to a database. And this all creates another so-called callback. And in this callback, you trigger the next function. So more or less, the Node application is actually a cascade of asynchronous callbacks that is at some point terminated by, for instance, returning some result.
Mm-hmm. Wow, and so that means, if I understood this correctly, if I develop a function in Node and I call another function, I typically do it by basically not calling the function directly as I would normally do in other programming languages, but I basically make an asynchronous request. So I say, I want to invoke that function and please wake me up, or please call this callback in case you're done. Is this correct?
Not directly. So your userland code usually, so when you do, I don't know, parse a string, echo something out, or do something, or process some templates, or calculate something, that's usually regular synchronous code. It looks like, so within a callback's return function, or it looks like regular imperative code. Like it's really sequential. The asynchronity starts every time you want to do I/O. This means you want to talk to maybe the file system, a database, do some request over HTTP. In this case, you will call the function like, for instance, fs for file system read. Then you have the file name you want to read, and then you add, as next parameter, you add the callback, the function that is to be called when this operation completes. So this means callbacks or this asynchronity always happens when you're doing I/O, and this then also runs not directly in your JavaScript userland code. There is another machinery in place that's called libuv. That's the event loop that really takes care of doing all those asynchronous jobs and then calling back the function when the asynchronous job is done.
Cool. Wow. And in that context, how is state that handled? Do I need to take care of my state myself by, I don't know, storing the state somewhere, or can I pass the state from one function until the next? How is this handled normally?
State handling is indeed like a little bit of a challenge. So it's easy to do when you do it for your when you do it like session handling. So the user state, keeping that is quite easy because it's more or less handled by the frameworks you use, like Express for web applications. And there you have the request object that is passed through most of your application, and then you can pick up the session from there. So there is enough kind of modules available that deal with that. It gets complicated but we are really getting deep here already, but it gets complicated when we talk about monitoring, because there you need this transactional state and this continuation state. And here I have to add, that makes it way more complicated, that Node.js runs in a single thread. Because it's evented, it can do that. So, for instance, if you compare it maybe to a PHP application, when their request comes into a PHP application, one single thread or process will handle this one request. And you can assume that within this request or this process, everything that's going on at a given time, it will be all for this one request. So it's easy to have a context or store a context global to this process. In Node.js, every request is handled by one process, just not at the same time. And this means that it's harder to, for instance, store state of a request state in your application and in one request. And that's a challenge for when it comes to monitoring, because you really have to do a lot of work called monkey patching to get this transactional state through all cascades of callbacks. Every time when you pass into the event loop, you are prone to lose your context actually. And things get quite complicated. We won't cover that, I guess. But yeah, it's a challenge.
Yeah.
So I think at some point we will want to cover some of the monitoring, maybe in a little bit. But I think before we go into the monitoring, because I'm sure there's a lot of aspects of monitoring Node, it might be great to frame, like, how is this being used? Where is it being used? In what context is it being used? Is this kind of a fast, cheap, and easy startup tool that once an organization gets more complicated and robust, they switch out to something else? Or is this something that can be leveraged for the long term? And if it is more long term, is it being really done in the whole the big microservices type of way we're seeing everything going on? What's the landscape of Node's usage, I guess, in short?
Yeah, so when I started at Dynatrace, I was also asked, so if Node is maybe the next Ruby on Rails, like, as you said, something like with Twitter, where you start with Ruby on Rails and then you shift away to maybe Scala or something, or Java or something else. And there already I looked at the landscape of companies that are investing into Node.js and are using Node.js. And if you look at them, these are companies like, for instance, PayPal, Intuit, Autodesk, eBay, IBM, also Netflix, Uber, NASA, or for the singles here, also Tinder. So these are all
they're big
Node applications.
Yeah.
And while, yeah, for sure, Uber and Tinder or Netflix are more or less startup-like, eBay or Autodesk or Intuit are definitely not. So I asked myself, what makes those real companies with a lot of legacy going on really use Node.js? And I looked for use cases for them, and I found 3 use cases that really clearly show how Node.js is used in the wild at enterprises. For instance, when we take Intuit. One guy, Alex Balash of Intuit, wanted to change something and wanted to create something new. And he kind of created the team he called Pirate Ship. So they worked after hours and really did things on their own outside of this usual company development scheme. And they decided to use Node for it. And that was TurboTax then, what they created with Node.js, actually. So it was a way to really quickly create something new. That's one use case. PayPal, for instance, switched to Node.js, and PayPal is meanwhile a real large Node.js shop. They had this regular Java infrastructure or system and applications, and this was quite monolithic. And one guy that was more front-endy, Trevor Livingston, found out that it takes them 6 months to change some piece of text on the landing page of PayPal.
Wow.
Because, you won't deploy the whole thing just for a text change, so So things
the
were really
waterfall kind of.
Yeah, it was really slowed down, and that was really a problem. So they used Node.js as templating platform first. So just to show how things could look like, and then moved that a little bit into the Java world by then using template compilers on Java, but that are basically were based somehow on JavaScript. But then they really took the step and moved the whole front-end part gradually to Node.js, and now very much of PayPal is Node.js. So here we have Node.js more or less also as a migration platform for existing applications. And third, a good example is also Walmart. Walmart, typically not a startup, very much legacy going on there. And Aaron Hammer worked as software architect there at this time, and he used Node.js as gluing tier, so as migration tier. He put the Node kind of Node in front of the whole enterprise stack and the whole legacy stack, and used it to enable new offerings to connect to the enterprise stack through Node. And that's the third use case. So so Node is first of all, Node is used by teams that are moving fast in companies. Node is used as a migration platform because it's easy to kind of move away from old things to Node. And it's also very much used as kind of, and that's a very frequent use case, as kind of gluing tier to really connect enterprise stacks, like also mainframes, whatever you have, to modern offerings like mobile apps or single page applications that are used to use JSON, and then there you cannot initiate some, connection to a DB2 or something. So this is all done within Node.js, and it's then transformed and kind of published to all those new platforms we have today.
No, go on.
And that's basically, I would say, the reason why Node.js became so popular. That does not mean that Node does anything very new. It was just a very easy way to have this whole asynchronity and a new platform. There are many JavaScript developers around. JavaScript is easy. So it was really around ease of use and providing a simple API to actually quite complicated computational or problems of computer science.
And I was just going to say, based on all those companies that you were mentioning using it, it's obviously not just it's great that it's not just a startup. It's something you can choose to use knowing it's proven, right? Especially on the enterprise level. If you're an enterprise customer, the risk is always, hey, we want to use one of these hot new technologies, but are we going to be able to keep using this? It sounds like, based on all those examples you gave, it's definitely although it's new-ish, right? 2009 when it first started. That's, not so long ago, but it's got a proven track record for sure.
Mm-hmm. Absolutely. I would maybe not use Node for. I just lately talked to one guy of a large German company, and they still have Java in the backend and everything. Yeah. And I would also say that Node is not a platform to replace really things. No one will shove out their mainframe and switch everything to Node, but that just does not happen. It's a platform to augment existing legacy or enterprisey stacks and make something new with them.
Yeah, I think that's a great explanation, especially the use cases. I think are very, very useful. Now, from a monitoring perspective, you mentioned it runs on V8, so I assume monitoring can be done by some tooling that comes with V8 itself when we talk about individual node instances. Is this a fair assumption, or is there nothing coming with the product with V8 itself?
It does, but that's mostly like more debugging or like tracing and not so much production monitoring what's provided with the V8. But sure, you can, and that's actually quite awesome. You can, for instance, create or collect heap dumps or CPU samples from a node process and use the output of that directly and load it into your Chrome developer tools, and you will have full the same functionality as if you would profile a browser application. Even more, there's now this new --inspect switch for Node. This will give you directly an URI you can put into your browser, into Chrome in this case, and then it will really even open a view for you that shows the code that even allows you to create breakpoints there. So you have in your browser, you have your application, and you can do in-place editing and everything and debug your application. So that's really a really neat thing, but it's possible because V8 is V8, and this does not care so much about the underlying machinery. It's still JavaScript, so it works.
And so that means, what are the typical IDEs though? What do people use to develop the code? Is this also the developer tools in Chrome? I don't think so, right?
No. So the IDEs to develop, I use, or not to mention a vendor, but the coverage in those JetBrains products is quite good. Then there is also, and it's really awesome and free, Visual Studio Code from Microsoft. So there you also see the investment, and Visual Studio Code is even done, as far as I know, somehow with Electron, which is basically Node.js again. So it's a Node application in a way, and it comes with built-in Node.js support out of the box. So you can open any Node application, and it will do all syntax highlighting, everything, and also offer you debugging facilities with a simple click for any given application. So it's really a great tool, and it's free. The only thing I'm missing there is for really larger projects, you might want to have something with a little bit more features. But for a regular project, Visual Studio Code is just a great IDE that does quite everything you need. Yeah.
Now, coming back to my monitoring question, obviously you can do debugging on individual nodes, but what are the main use cases why developers or people that run node applications go to a commercial provider or let's say an APM vendor like Dynatrace? What are the use cases that we provide that are not handled by the debugging features that are coming with V8?
So the thing is, when we talk about monitoring, and I think that's really key, and that also took me a while to learn in the beginning, was that we rarely deal with those developers, right? So with those people that that actually wrote that code, application performance monitoring. And if we talk about enterprise scenarios, always involve some other teams like operations teams that kind of keep the whole thing running. And usually Node.js is just another tier in this whole landscape they have. And we see this very often, Node.js is a very important tier because it's the very often kind of a proxy tier. And I forgot to cover that with my use cases before. Also the tier that handles all those microservices. Node.js is great for microservices, by the way. And then if you don't have the coverage of Node.js, you lose a lot. Why? Because you want to see the transactions passing through your application, because that's the only way to really nail down a root cause. So if a user clicks on something and something breaks down the stack, you want to see the whole transaction passing through all tiers. And to get that, you have to monitor Node.js as well. And that's, for me, also the most important use case. I can talk a little bit later about metrics within Node.js that are important, but this transactional tracing through Node.js is really key from my point of view. And that's also what I was talking about before, that it's quite hard to kind of have a request coming in and not losing kind of this request ID on your way through all those callbacks. And when the request then leaves the Node tier, for instance, to call some Java backend, this request ID should be on this request again to be picked up on the Java tier, for instance. And this is really a challenge in Node.js.
Yeah. Cool.
And in those node calls, and in those node calls, would you say like most, some, or all, or what percent of node requests that hit the node tier go on to another sub tier from Node, like to Java or somewhere else? Or maybe does Node sometimes go directly to the database? Or is it situations where Node's handling everything and just sending it right on back?
I think my knowledge here is a little bit filtered because our customers are mostly enterprise customers, and they use Node heavily as gluing tier. Okay. So as proxy, and most things are kind of going through the Node tier. For instance, Node does some authentication or something. So Node, most of the time when I ask the customers and they say, does Node.js talk to services down the stack? It's always a yes. And it's not so often even the database. Sometimes that happens, or it uses Redis for some kind of session management, etc. But down the stack, there is, in most cases, some kind of enterprise-y, like Oracle database or some data warehouse or whatever. And that even applies to those now, I would say, modern microservice platforms, because those microservices are, I would say, like a cloud around those enterprise-y cores companies have. So those microservices still reach down the stack and talk with some APIs or with some services that are not Node.js, often Java, sometimes .NET, something like that.
Yeah, and that was kind of a setup question. I sort of knew the answer, but just to illustrate kind of that, when you're looking at the response times of your transactions running through, it's not enough to just say, okay, it's a Node transaction. We have a Node problem. It could still be anywhere in that stack because there's a lot of different places where Node could be reaching out to other services or other components that it can be interacting with. It's not this self-contained component. And Andy, that I just wanted to bring that in as you were going into that monitoring, because I think it was just kind of important to establish that Node is not just a standalone node, but that whole deeper view there. So.
And I think I have to add here that also the Node teams, they are, as I said, very often very fast moving teams in organizations, really have to get into this mindset as well to be part of kind of a bigger whole in a way, because I see often that Node teams are kind of doing their own little monitoring for Node. dedicated for Node, and they think they are set with that. But when something goes wrong, they might be the first to blame when something goes, because that the errors first occurs then on Node.js, because it's the very first tier it hits, and also when the transaction fails down the stack, the error, there might be exception in Node.js, and then it will be the Node team that is to blame for. So it makes really sense to to have a holistic view of the whole application to find root causes where they happen. Yes.
Hey, before I ask you a little bit more about monitoring and also like what to look for, what are the typical platforms then that people run Node? I would assume it's heavily Linux based, or do you also see other platforms?
We see really mostly Linux. So there sometimes we see Windows, but that's very rarely. That also has something to do that the Windows support of Node was not so great for a while, and so that's more or less also historically. You have to consider that while Node.js is JavaScript, and the V8 also runs on Windows without a problem. You see it every day on your Windows machine, on your browser. The event loop that kind of delegates all those jobs, asynchronous jobs, to the operating system actually really heavily relies on the operating system it runs on. Because it really utilizes kernel functions there. So it really makes a difference. So the implementation is hugely different. So if you're kind of listening for a kernel event in Linux or on Windows, so these are really different things. And that's the reason why historically I think Linux is, by far the most used platform here. But honestly, Linux is in all those server environments most of the time.
And you mentioned that Node.js is executing on a single thread. So does this really mean that every time I launch a Node instance, that I really only get one thread, or do I get a thread per core, which would be probably more, which would I guess also work to be more efficient, or how does this work? Is it really just one thread?
So there are a few things. First of all, you can start Node using the built-in core module cluster, and this will basically spawn worker threads, those child threads, and will then internally use inter-process communications to delegate load to those childs. You do this also code-wise, like you would do it in other languages. So you ask if is master, you do something, or is child, you do something else, and then Node.js will take care of the rest. So usually you then create cluster processes times number of CPUs. Makes sense. So you usually have then times CPUs plus one, because that's the master process that kind of starts in the beginning. But that's just one piece of the story, because when people talk about Node.js, they very often also mention a thread pool of libuv, of the event loop. So Node also maintains a thread pool, which I think it starts with 4 or 8 threads or something like that. And people then tend to say, okay, then we are back at regular threading, right? Because there we have the thread pool. But you have to know that libuv sometimes delegates tasks to the thread pool, to a thread, and this thread will do the task and then will come back to libuv, and libuv will call the callback. But this is not the most frequent case, because very many APIs, interfaces of modern operating systems already are asynchronous, so it can be directly used then by libuv, and they will call the native interface that is asynchronous already and does not have to delegate to the thread pool. Just in rare cases, it might happen that the thread pool is utilized to do some asynchronous task if there is no better way available for that. But and then we also have a few threads by the V8 engine also will spawn a thread, for instance, I think for garbage collection. So there are some kind of workers that will start with Node.js, but your JavaScript code and also the event loop will run on one single thread, and if you spawn it, you have on one single thread per CPU.
Mm-hmm. So that means scaling. If I have a powerful box, then if I want to scale Node.js, it doesn't actually make sense to spawn multiple instances, because the idea is that we are leveraging the CPU in its best intention anyway, because we're always, thanks to the event model, are never putting the CPU in idle, even though if we have just one node instance running with however many worker threads. So that means one node instance can fully utilize the CPU.
Yeah, one CPU. So one node instance can utilize basically one CPU at a given time. And if you have more cores, for sure, start one for every core. But the CPU is best utilized already. So I think that causes a lot of confusion sometimes, because they think of the event loop about some kind of totally deterministic machinery, but there are a lot of heuristics in place here. So it really tries to do smart guesses how to utilize stuff. And that's exactly what I was talking about before. The Node.js provides a simple API to complicated processes, because if you do this on your own in Java or in C or whatever, you have to take care of that yourself.
Mm-hmm. Cool. All right. I think what I would like to conclude this topic with, and I know we said we wanted to cover both Node.js and serverless in a kind of like a 30-minute sessions, and we've already been talking 30 minutes on Node.js alone, but I think this is just so valuable. I would love to wrap up this Node.js specific topic by asking you now, on a monitoring perspective, what are the things that people look for besides obviously the end-to-end tracing? What are the things people look at to optimize their code that is running? How do they find hotspots? What are the typical hotspots? Is it bad coding? Is it memory? What are some of the things you've seen out there?
So there are a few things. First of all, Node.js is a long-running process. So this means not like in maybe PHP, there one process lives for just one request. You start this process and then it handles requests. And so you're prone to every kind of memory leak you can think of, obviously. So you can store something in global scope that will kind of clutter your memory, but you can also have some garbage collection issues within Node.js, and they will kind of, where it's no problem in PHP, because for those 1 second before the process dies, everything kind of gets for this 1 second, that's no problem. But if in Node.js this runs for 3 weeks, you see how the memory gets consumed. So first of all, collecting heap dumps is one thing, or looking at memory usage and also garbage collection runs. How long do garbage collection runs take? For instance, do I allocate a lot of objects here, and does this really slow down my application? Because every time the garbage collector runs, the node process will be stopped. So these are things you want to look at. Then for sure, CPU metrics are interesting. So how much CPU am I using actually? Like for every other application, that's an important metric. And then, and this is something we are just getting ready now, event loop metrics are important. This means we measure, so one event loop run is called a tick, and we now created metrics that measure the duration of one such tick, and also the latency and how many, or also the frequency of event loop runs. And this tells you a few things. This can tell you, for instance, if the event loop is blocked for some reason, like waiting for some I/O, or if it's doing a lot of JavaScript code or userland code. So if it's heavy on the userland side, so you see all of that in those event loop latency metrics, and this also tells you a lot about what's going on in your code. So there are two things for sure that can cause Node to slow down. First of all, for sure, it talks to some slow process via I/O, like, I don't know, some HTTP, some REST API that is responding slow, that will, for instance, also slow down the event loop because all those pending requests pile up in the event loop. Or there's another thing that would be when you in your userland do, and you should never do that, actually do CPU heavy computations. But this can already start with string manipulations or parsing large JSON objects. This really can cause your application to slow down. And that you would see that basically through the event loop metrics or through CPU sampling, of course, as well.
It's funny, and a lot of those problems I hear as, although framed a little differently and different characteristics within Node, they all kind of tie right back into the same common problem patterns, with the string manipulation and too many requests to another tier. It's just a different flavor of it.
But in Node, the problem is differently to other kind of platforms is if you take, I always take PHP because it's such an easy example. If you take PHP and you do something very CPU heavy on one process, on one request, all other requests can still be handled, right? Because it spawns a new thread and you're done. In Node.js, if you have one single thread and you, I don't know, calculate Fibonacci somewhere in your JavaScript code, and this takes 2 seconds, then within these 2 seconds, really nothing happens in your Node application. So it cannot even take one single request. So you can really halt everything with such operations. So that's the critical thing. That's the reason why you should never do CPU heavy stuff within Node.js directly.
Cool. Wow. Hey, Daniel, I know we could probably go on much further, and I know there's a lot of more material out there. You are a regular speaker, you're a blogger. But I think I want to conclude that topic for this episode and then invite you back for another one on serverless. But kind of to sum up what I learned is, where Node.js came from. It's been around for a while. Thanks especially for the summary and overview of all the different use cases, especially in the enterprise that we are dealing with. It seems to be often used as a gluing tier between the new projects that are going on and the enterprise stack that is there. Also, obviously it allows certain teams to move much faster. That's great. I learned a lot about architecture, and thanks a lot for explaining the different monitoring use cases. And it seems really what we try to solve as Dynatrace and as other APM vendors probably in the space is making sure we can not only monitor a single node instance, because that is rarely ever the case or helpful in a large production deployment. You really need to understand the end-to-end transaction flow when it flows through Node.js and what's happening there. Is this kind of a good summary, would you say?
And concluding, I have to say that we are in the Node Diagnostics Working Group are really trying to get even better transactional tracing in Node.js, because every vendor, and we have a few APM vendors in there, are kind of facing the same problems here. And we are really working on a generic solution to make monitoring of Node.js applications even better.
Great. And cool. I wanted to say thank you for using the word Fibonacci. You're the first to do that, and if I could give you an award, I would. It's a long-standing inside joke with me and my friends, but I don't know if any of them even listen. So it gave me a great feeling, though, to hear that. So thank you. And the other big thing I wanted to point out, right? You were just stressing the whole bit about the large CPU consumption and processing, and how monitoring CPU utilization in Node is very important. And you also mentioned monitoring garbage collection is very important. And that then brought back to mind, Andy, our conversation just about garbage collection in general when we were talking about memory, how one of the most important things to be able to see is the CPU utilization of garbage collection. Because if you are not seeing that garbage collection specifically, GC is going to show up as CPU. Right, so GC uses CPU. So the importance of being able to see this is code execution CPU versus this is garbage collection CPU execution is very, very important. yeah, just wanted to bring that up, because if you're just looking at that CPU, it's hard to tell, is this something intensive in the code, or is this GC? So being able to monitor that is key, I think, as well. Yeah,
and luckily the V8 engine in this case of Node just has events you can listen to for GC runs, so it's quite simple to time them and to graph them out.
Great, excellent.
Cool. All right, let's wrap up this episode, Brian.
Yes. Daniel, do you have any engagements? This is probably going to be airing in June, I think. Do you have any summer engagements that you'll be speaking at or attending that you would like to promote?
I cannot tell yet. I might be at Node Summit. Node, I think it's called Node. 1 second, give me a second. Rephrase. It's
Andy, give us some music.
Yeah, I might be at Node Summit in San Francisco. Okay. I cannot tell yet. I was invited to the board of those people that kind of vote on the submissions, on the call for papers. So I hope this also means I will be in there as well.
Okay.
I cannot tell yet. So, and next most probably I will be at Node Interactive in Canada, sometimes in fall. But yeah, I don't know yet. It's mostly most things are really on a short call usually.
Okay. And we will post links to your blogs and everything up on the site for this. And well, again, thank you very, very much for taking the time. I found it very enlightening, as always. And want to thank our listeners for being with us all this time. And any questions or feedback, if you want to hear, if you have any specific questions, this is a great opportunity since we had to delay the serverless talk. If you have any questions you want us to address on this serverless conversation, go ahead and either email them to pureperformance@dynatrace.com, or you can tweet them to @pure_DT, or you can also reach out to Andy at GrabnerAndy, or me at Emperor Wilson. Daniel, you have a do you tweet?
Yes, you can reach me at dkhan, so DKHAN on Twitter.
Excellent. Any last words from anybody?
No.
That was
all good.
Those were last words. It's a trick question. Got you again. All right. Well then, until next time, everybody. Thank you and
thank you very much.
Good.
Bye.